So let's take a look at efficiency and conservation. A lot of times you will see these terms used interchangeably, but I think it's important to point out that they are actually different terms. They refer to different things. So efficiency is getting the same or similar output with less input. Or you can think about it in another way as getting more output with the same input. So we're going to go over an example of this in a minute. But you've all, I'm sure, used the term efficiency, or you're more efficient with, you have a more efficient car, or a more efficient light bulb, or you're more efficient with your time, whatever. So this is a term that we're familiar with. I mean, we know what it means intuitively, but what it means in terms of inputs and outputs is really important in the world of energy. And so it refers specifically to this phenomenon where we get more out by putting the same amount in. So a really good example is light bulb. So with a light, so on the left here you have your incandescent lamp, and if these two lights have the same output, okay, so the same output, this CFL, or the compact fluorescent lamp, requires less energy input to get the same output as the incandescent. Okay, so we'll go over kind of look at this in a little more depth in a minute here. And there are many other examples. I mean, you have efficient furnaces, efficient cars, efficient TVs. There's all kinds of examples of this. Now, conservation means something different. So conservation is changing your behavior to reduce output. So this, especially in terms of energy, conservation refers to a behavioral change. So you are reducing your output, but at the same time, you're reducing the input. So you're changing what you're getting out of it. So, if you think of efficient lighting as an example of efficiency, and an example of conservation would be just turning off the light switch. So in this case, when you have to change your behavior, you have to do something different. You have to turn off the lights. If I'm using these light bulbs, I just leave them on. I don't have to do anything. And I'm using less electricity. In order to engage in conservation, it's a behavioral change. You have to physically turn off the light bulbs. But more importantly, you're not getting the same output out of it. So you're reducing your input, but you're getting less output because the output, remember, is the light that you're getting out of it. Excuse me. And so in this case, you're not getting that light out of it. So it is a different phenomenon, and I want to make sure you keep those separate. And there are other examples of that as well. So let's go through a little kind of thought experiment here to illustrate some of this. Okay, so looking at efficiency as our example here, let's think of a few things and how the inputs and outputs interact. So let's think of just in general terms, a light. So we have a light bulb. Okay. So my input for a light bulb, hopefully you know this, is going to be electricity, right? My output, my useful output, will be what I want to get out of it. It's pretty straightforward. I just want some light, okay? So let's look at, this is just, in a general sense, what we're looking at. Let's look at two examples. So I actually looked up some information here. So you have a compact fluorescent, you have an incandescent, which is your old school light bulb, and then what's called a light emitting diode, or an LED. Okay, so in order to get almost the same output, in fact, it turns out to get, so the light that you get out is measured in lumens. So to get, I looked these numbers up, so 1350 lumens and 1200 lumens, okay? I'm sorry, this is for a, apologize, this is for a halogen. So for a halogen, which is a sort of a more efficient version of an incandescent. Okay, so this is our useful output. This is effectively light, okay, the amount of light you're getting out of it. So with a CFL that's getting this many lumens out is going to require about 23 watts. Okay, so this is power. So this is electric power. So in order to get less light out of the incandescent, you're going to use about 100 watts. Okay, so this is actually more input and you're getting less output than the CFL. And with a halogen with a 72 watt input, you're getting about the 1200 out of it. So you can see here that the CFL, you are using the least or the lowest input, And actually, you're getting the most output out of all three of these choices. So that's what efficiency means. You are reducing your input and you're getting the more, or excuse me, more or better output. So let's look at one more example. So let's look at a car, okay, or an automobile. All right. So what do I want to do with the car? What's my useful output? Um, and you could say, miles driven or mileage, whatever. Okay, you want it to get you from A to B. So my input, in order to get my mileage out, I have to input gas. Okay. So if I look at a few examples, you've heard of efficient vehicles. Well, this is what an efficient vehicle means. So let's say, you have your Toyota Prius that gets about 50 miles a gallon. So let's put that here, 50 miles gallon, okay? So if I have 1 gallon of gas, I'm going to get 50 miles out of it, okay? So my input, gallons, my output, mileage. Now you look at like a Subaru, okay? About, on highway, you're going to get about 1 gallon will get you around 25 miles, okay? So what do we have here? We have the same input, okay? Same input. And with the Prius, we're getting a greater output. So again, more output, same input, okay? Another way to look at this, let's go with our Prius again and Subaru. So if I want to go get the same output, okay, so if I want to get 50 miles in a Prius, all right, I need 1 gallon. With the Subaru, I need 2 gallons. So the subtle difference here is you have the same output, but something that's less efficient, you need greater input. Whereas if you have the same input, you get more output out of the more efficient, okay? And so that is one way to demonstrate what it means to have something that is more efficient.